This question comes from a viewer named Leo, who asked something that sounds like pure poetry. What if every grain of sand was actually a tiny microscopic star? It sounds like the setup for a beautiful fairy tale or a line from a cosmic poem. You'd have a universe in the palm of your hand. Stardust wouldn't just be a metaphor, it would be your beach towel. But what if we took this beautiful idea literally? What if, tomorrow, all the sand on Earth, every dune, every hourglass, every sandbox was replaced with perfect miniature replicas of our Sunday? In the spirit of Randall Munro's What If, we're going to follow this thought experiment down the rabbit hole. We'll discover that this poetic swap would turn a day at the beach into a physics adventure featuring nuclear fire, unexpected darkness, and a very serious talk with the planet's insurance company. The beach of a billion suns. Let's start with the scale. A single grain of sand is tiny, about 0.5 millimeter across. Our sundae is a giant ball of plasma 1.4 million kilometers in diameter. To cram a sundae into a speck of sand, you'd have to shrink it down by a factor of about 3 trillion. That is a mind-bending level of miniaturization. But okay, physics is already on vacation in this scenario. Let's say it is done. You walk onto your new stellar beach. Your first thought might be, it is so beautiful. And it is. Each grain is a perfect self-contained fusion reactor, glowing with the fierce concentrated light of a full-size star. A handful would be brighter than 1,000 welding torches. You couldn't even look at it without instantly burning your retinas. Forget sunglasses, you'd need a spaceship viewport. Your second thought, a fraction of a second later, would be, it is so hot. A star's surface is about 5,500 degrees Celsius, 10,000 degrees Fahrenheit. Even scaled down, the temperature of that plasma doesn't change just because the star is small. It is not about size, it is about the nuclear fusion happening in its core. Each microscopic star is a 5,500 degrees Celsius bead of pure fury. A single grain placed on your kitchen counter would instantly vaporize it, starting a fire that would make a volcano look like a matchstick. As Randall Munro points out in What If, when discussing a tiny star on Earth's surface, the heat and radiation would be instantly lethal on a planetary scale. The beach itself would melt into glass and then vaporize. The ocean would boil away. The atmosphere would cook. So for this to be even remotely discussable, we have to add a magical safety rule. Let's say the stars somehow emit light, but not the devastating heat and radiation. They're decorative stars, otherwise the video ends here with a cartoon mushroom cloud. Life in a glowing world. Okay, with our magical heat shield engaged, what changes first? Night is cancelled. Deserts like the Sahara, beaches, and riverbeds would become permanent, colossal light sources. The entire Earth would be lit from below by a gentle, omnipresent glow. Astronomers would riot. Stargazing would become a nostalgic memory, like using a dial-up modem. Second, sand becomes the ultimate energy source. Forget solar panels. You could power a city by putting a handful of this star sand in a light-capturing chamber. The global energy crisis is solved overnight. The downside, the flashlight industry collapses. Sorry, flashlight industry, but there are subtler problems. Munro-style physics always finds the subtler problems. Sand is useful because it is inert. We make concrete out of it. We put it in hourglasses and children's play pits. What happens now? You can't make concrete with stars. The mixture would glow, and the cement would probably get confused. Your new patio would be a local landmark and a navigation hazard for airplanes. An hourglass would become a beautiful light show timer, but more importantly, sand gets everywhere. It is the universe's most persistent tiny traveler. Now imagine glowing, stardust getting everywhere. Your bed, your keyboard, between your couch cushions. Your life would become a never-ending cosmic cleanup. You'd find constellations in your socks, the crushing truth, and the final sparkle. Here is the real kicker, the thing that brings our poetic idea crashing down gravity and pressure. A star like our Sunday exists in a perfect balance. The immense gravity pulling it inward is counteracted by the outward pressure from fusion in its core. In our grain-sized star, that balance is shattered. As Munro explains in his books, if you somehow compressed a star's mass into a tiny space, you'd get something else. A teaspoon of Sunday material, its core weighs about as much as an elephant. A microscopic chunk of it would be incredibly dense. So our sand wouldn't be light and fluffy. Each grain would have tremendous density. A bucket of this star sand would weigh thousands of tons. It would immediately sink through the Earth's crust like a bullet through fog, headed straight for the core. The beaches and deserts wouldn't just glow, they'd be unimaginably heavy, tearing the planet's surface apart under their own weight. The beautiful glittering dune would act like a neutron star's blanket, crushing everything beneath it. So, what is the verdict on star sand? As a poetic idea, it is gorgeous, a reminder that we are, in a very real chemical sense, made of star stuff. But as a physical reality, it would be a cataclysmic mix of searing heat, world-breaking density, and permanent light pollution. It turns out, the universe has already done us a huge favor. It took the raw materials of stars, cooked them in supernovae, and scattered them across space where they slowly, safely cooled into the wonderful non-nuclear, non-crushing sand we know today. So the next time you feel sand between your toes, you can still think about the stars. But maybe be grateful that it is just regular, boring, non-fusing silica. It is the only reason we're here to enjoy the beach, and not become part of it in a very literal atomic way.